Welcome to another Moralis video, and in this video I will show you how to build a subgraph for NFTs on Base. And you will learn how to build a subgraph for indexing transfers, IPFS metadata, and ownership of NFTs on Base. And the end result for our subgraph will look something like this. So you'll be able to query for users, as we call it, which is owners, and all of their tokens, all of their images, the full metadata in JSON format, and the name of the NFTs. And you'll be able to get this for all of the tokens and owners in a specific collection. And in this video, working with the Base Golds collection on Base, but this will work for any collection on Base. And it is similar to how we do it on any other chain, by the way. Base is just an example here. But more than just coding this specific subgraph, you will also learn the differences between using just a blockchain node, using a subgraph, why we even have them in the first place, why they're needed, and then also the difference between a subgraph and using blockchain APIs like what we have over at Moralis, and maybe in which situations that you should use either of these three. So it's going to be a knowledge-packed episode, so strap yourself in, we're ready to get started. It's going to be an exciting video. We're going to start by talking about why we even need indexers in the first place. And we're going to start this by talking about the limitations of blockchain nodes and smart contracts. Because with blockchain nodes, you can query any smart contract function, but they are quite limited. And the functionality can be shown by just going to Etherscan or Basescan in this case, and looking at the functions here for the Base Gold smart contract. And this is the ERC 721 standard contract. You can call things like owner of, for example, which means you input a token ID, you query it, and you get back the address. But what if I want to see which NFTs this address owns? Well, that's not something that I can query here for. I can take this and I can query the balance of function, but that will only give me how many NFTs this address owns. It will not tell me which ones they own. For that, you would need to index this smart contract. And you would need to basically check for each transfer who is the owner of the NFTs. And that's what an indexer does. So back to the presentation here, you can call smart contracts using blockchain node or any of the libraries and SDKs that you use together with an RPC node. You can query, for example, the balance function for a specific address and a specific contract, a specific token ID. But what if you want to get all balances of either an address or just all balances in the contract? Or maybe you want to get top 10 biggest balances, or you want to get all of the owners of this token. Or maybe you need metadata. Like you saw, we only got back like the address or the balance. There was nothing about the name of the token or the metadata of the token, the trait, the image, nothing like that. And that's because the blockchain nodes are very specific for dealing with one specific thing, and that is who owns what. Like they're designed for that, not to carry metadata or to be nice to query for a bunch of other data points. They're there to keep track of who owns what, and they're very good at that. But this is where subgraphs and indexers comes in, because with that, you can index one smart contract or more for specific events. So you can tell a subgraph that, hey, I want to index all of the transfer events. So I can query for all of the transfers, for example, or I want to index all of the owners to keep track of as transfers happen, who owns what, which is what we're going to do in this video, by the way. And you do this by building your own schemas and then querying using GraphQL. And you'll see exactly how we code that using TypeScript and how we query it using GraphQL. And that's very good. Now we can answer all of these questions that we have here. Get all balances, get the largest balances, get all of the owners, and we can even include metadata from IPFS, which we're also going to do in this video. But as you'll also see in this video, there are some drawbacks when using subgraphs, and there's also some limitations that we'll get into. Number one, it takes time to code them. It takes time to sync, and every time you make like a mistake or you need to recode something, you need to resync, and that takes time, which can be very frustrating. It's also contract specific, meaning that you index one contract at a time, and contracts can be unique. So if you're building things like a wallet or a portfolio or an NFT marketplace with many collections, where maybe people create new collections every day, and you want to query things like what are the balances of this wallet for any NFT, then subgraphs and indexers are not really going to work for that. They're contract specific, you index one contract at a time, and they're also blockchain specific. So if you want to query for collections on one chain, you need to launch subgraphs for that chain. If you want to do it for another chain, you need to launch subgraphs across many different chains. So it doesn't scale very well for those purposes. And then you have Moralis APIs. And this is like a different category of solutions. Here, Moralis indexes the entire blockchain to enable for way more powerful queries. You can do now cross-contract queries. So not only like give me all the NFTs of this collection and who owns them, but now you can also do things like get me all NFTs of this wallet, spanning all of the contracts on the blockchain. So regardless if they have, base DGODs or they have 10 different NFT collections, you can get them all in one call. You can also get way more metadata, as you'll see later on, with things like images in different resolutions. You can get the metadata all pre what's it called? English as a second language struggles. You can get pre-formatted so that you have uniform formatting across all different collections. You can get things like prices. You can get like decoded events and logs, and you can do this across all contracts and blockchains. And there is no coding required. There are no syncing times. So there's many benefits with using an API. The only downside to using the API is that it's unnecessarily. The only downside to using an API is that if you need custom stuff, like you want to index a specific event that Moralis might not index. So if you go outside of like balances and transfers, you have some custom event and you're working with a specific contract, then it makes a lot of sense to use an indexer. For many of the things that we're going to do in this video, it's more of a learning experiment to see how subgraphs work and learning how to customize them to your liking. But it might not be a great example of the best use case for a subgraph, because you could use Moralis APIs out of the box for this. But it is a very good lesson to learn if you're interested in indexing custom events later on in your career or in other projects. And here's an overview of just using nodes or libraries like ethers or an indexer like subgraphs or Moralis APIs. In that, can you get native balance? Yes, you can get native balance from all of these different solutions. Can you get token balance for one token for one address? Yes, you can do that for all of these, even with just a node. Can you get all the transactions in the block? Well, yes, you can with nodes. Actually, you cannot with a subgraph, but you can with Moralis. But then we get into the things where the nodes set themselves, or the indexer sets itself apart from just a node. If you want to get all balances of a specific token, you cannot do that with just a node, but you can do it with an indexer. Can you get NFT metadata with just a node? No, you cannot. You need to index it. But then we get into the things where you cannot even do it with an indexer, which is things like get all NFTs of a wallet. Now we're talking about this cross-contract stuff. You cannot do that with an indexer because you can only index specific smart contracts. Get all assets of a wallet address like tokens, NFTs. Get the floor price of NFTs. You cannot, or get full wallet history across all different assets. It's also something that you cannot do if you're looking to build in a wallet or a portfolio, like the transaction history like you would have in Ethereum or MetaMask or so on. You cannot do that with an indexer. You need an API service like Moralis. So this is the difference between the two solutions. And now we're going to get into actually building our subgraph. So you'll see how we go from just raw blockchain events into an actual subgraph API that we will index and then query. And we're going to start by going to the thegraph website, thegraph.com, and scroll down to where it says build a subgraph. Or you can also go directly to thegraph.com/studio. You might need to sign in the first time that you're here. But once you've done that, you can click on create a subgraph, and we'll name this base NFTs. You can name it whatever you want, it doesn't matter. Hit create subgraph, and then you're going to need to follow the instructions here on the right hand side. And you're going to need to bring out your terminal, and I'm using the Visual Studio Code terminal here. And we're just going to follow the documentation here on the right. So you need to have the graph CLI installed, either using npm or yarn. And then we're going to run this graph init command that will initialize our subgraph. So we're going to copy that, and we should be in a directory where you want to create your folder for this project, because this will create a folder called base NFT. So I'll be in my documents folder, and I'll paste that in here, graph init studio base NFTs. And then we'll be guided through like a little wizard here. And we're going to select the Ethereum protocol, which includes any L1, L2s based on EVM. So that includes base. We're going to hit enter, and then we'll be asked for the slug, and that will just be base-NFTs. Directory will just be base NFTs also. You can select your directory there. Then here we select the network, and there's a lot of networks, and you can select base testnet, base Epolia, and then a bit further down you have base. Don't ask me why it's not in alphabetical order, but here is base. Hit enter, and now we need to input the contract address. And then this is going to depend on which collection that we want to index. And when you're doing a subgraph, you can only index one specific contract at a time, or a set amount. You can input multiple contract addresses into a subgraph if they have the same standard. You can run the same schema on them. But it's not that you can just index all of the NFTs using a subgraph. They are contract specific. So we're going to need to find a NFT collection on base that we want to index. And for that, I thought we'd go to dapp radar. We can go into NFTs, select the base chain, and then look at some of the top NFTs. And I thought we would do this one, the base gods. And for this one, we'll need to get the contract address, which is here at the bottom. And then we'll go back to the terminal and just input that here. We'll paste that in here, the contract address. And they will fetch the API, which is the interface of the contract. And then it also tried to fetch the start block, meaning when this contract was first created, but it failed. So do we want to retry? No, we'll press N. Then we need to input the start block manually. And for that, we need to go to the base explorer, input the contract address here, and then find the very first transaction. So we'll go to the token tracker for base gods, and we'll go back to the last page of transfers. And here we can click on that transaction, and we will take the block number. All right, we'll copy that. And go back to our terminal and paste that in here. Oops. There we go. And then contract name, we'll name this base gods. Index contract event as entities, we'll just hit enter true. That will index all of the events for us and initialize the config. And then it will do some work here. In the meantime, we'll go back to Subgraph Studio. And after this, it will create this subgraph folder for us where we can authenticate ourselves and then deploy it. So we'll wait for that to finish. And then it will ask us if we want to add another contract. In this case, we'll tell it no, we want to continue. And now it's done. And now we'll follow the rest of the instructions here. So we'll authenticate in the CLI. And we will cd into our folder. We will run graph cogen and graph build. I will run these independently, but you can copy it from there. Graph cogen first inside of our folder, base NFTs. It will generate our schema, and then we'll run graph build. And some error. Something address is not assignable to type something bytes. Entity allowed C drop base gods line 38. Okay, so I'm gonna have to open up this folder and we'll see what's going on. I'll now I have a new terminal. I'll open, or I'll try to run this again just to get the error message back. But this is, yeah, the downside of doing this subgraph versus just using an API would be that you need to handle all of this stuff. Source, base gods, and we'll see line 38. So it's this line here where there is some mismatch between the types. And since we won't use this handle allowed seed drop event at all, I think I will just delete it. Let's see, allowed seed drop. Yeah, I'll just delete this function. I'll delete allow seed drop updated from import statement. I'll remove it there. And then I will also remove it from the schema as a type. And also from the YAML file, I'll remove it as an entity, and I will remove the event handler here. Save that, and we'll try again. See if that did it. We'll do graph cogen, graph build. Please. There we go. And yeah, it doesn't matter in this case because we wouldn't have been using that event anyway. We're more interested in the owners, the transfers of the tokens. So now we can deploy this. We'll go back, open up our Subgraph Studio again. We already did this, so now we can deploy it. Okay. Graph deploy, base NFTs. Let's go. Version label, I'm going to use version 0.1. Build completed, deploying, there we go. So now we can check out the graph page, which should have updated. And now it is syncing. So this, depending on if someone has already indexed this in the past, the same thing as you do, it needs to sync. And that can take anywhere, depending on what you're indexing and how many events there are, anywhere from maybe 15 minutes or maybe even 1 minute if it's a really small one, but usually maybe like 15-20 minutes to, I mean, hours if it's a really big one that no one has indexed before. And you can track the progress here in the logs, and track the progress here, by the way. So 80%, but it started at 80%. So we'll see how quickly this goes. But in the meantime, I thought we could check out, while we're waiting for this to sync, we can check out how this would work using the Moralis API instead. And then we'll come back and we'll finish this build. We'll try it out and then we'll improve it to get some more data into this subgraph. If we head over to docs.moralis.io, we can check out the Moralis API. And all of the Moralis APIs are available on Base. So there's no difference depending on which network that you're on. All of the Web3 APIs are on Base, the Streams API, and the Market Insights API. So in this case, we can have a look at, for example, the NFT API. And just to clarify, the main benefit of using something like an API instead of the subgraph is that you don't have to do any syncing, you don't have to do any coding to get the API up and running, you don't have to fix these types of errors that we received when we're trying to set up our subgraph. And as you'll see soon as well, the subgraph that is currently syncing does not have that much interesting data. We need to do a lot more work in order to get actual, metadata into it, holders information into it. And then that's just for one collection. So depending on what you're building, that can work. But if you need data across, all types of collections, meaning you want to know, for example, which NFTs does this particular wallet hold, then you won't be able to do that with subgraph, regardless of how much you code. So you'll see those limitations later, but let's just check out, for example, something similar that we'll get from the subgraph eventually, which is just all of the tokens of the collection. So we'll go to get NFT metadata and get, or let's see, what am I going to do? Yeah, get NFT. Oh no, sorry, we're going to get NFTs and get NFTs by contract. That's what I wanted to show you. So basically get back all of the NFTs from the collection. And here you can see all of the arguments that you can input. You basically just input the address of the contract. For us, it's the dgods or base gods contract, sorry. You input that and you select the chain base. you choose the format of token ID, but in this case we don't have any. You have a bunch of other options. The normalized metadata and media items are pretty cool. We can enable those. We'll get back all the metadata in a formatted way together with the NFT images in different sizes. But I'll show you the same request in Postman instead. So here it's the same request I've prepared. So it's the Moralis NFT API with this contract address. Chain is base. Maybe I need to zoom in even more. Chain is base. Format is decimal. Normalized metadata is true. Media item is true. And the response looks something like this. So we'll get back all of the tokens in an array with things like the name, the symbol, the token ID, the token URI, which is the metadata URI, the metadata in string format. You can see when it was last synced, who minted it, if it's spam or not, if it's a verified collection or not. In this case, it's true. Then you get this nice normalized metadata, which we enabled through the URL parameter, where you get all of the metadata in a similar format, regardless of which collection you're querying. You can see all the attributes of this particular NFT. The background is peachy, the skin is groovy, the claws have a windbreaker, mouth is a cigar, eyes is interdusting, whatever that means. Now you saw the docs page is refreshed in the background. But this is a lot quicker if you just query it directly through the API. It's the docs page that is slow. And then you also get media. So you get back low, medium, and high resolution for the NFT, which is pretty darn cool. So we can open, for example, the medium resolution image. Oops, we'll have to copy that into our browser. And there you can see the NFT. There we go. And you can also see the original media URL. And then you get this for all of the token IDs, and it's a massive response for the first 100, and then you have to query the next page and so on. And that is how the API works, and that is available for Base, for any other chain, for ETH, for Polygon, for Binance. And of course, this is just one of the endpoints. Get NFTs by contract. You can also, what I was alluding to before, get NFTs by wallet, which is not something that's available through a subgraph, because here you'll get back all of the NFTs that is owned by a particular address. So let's see how we can find this. We could go like to Etherscan. We can find a holder here. So this person, let's say, has 23 base gods. Let's see what other NFTs on base, or maybe let's take someone that has a bit fewer, so it's not that long of a response. Let's check out this guy, see how many other NFTs this person has. We'll get NFTs by wallet. We'll input his address here, select base, and then we'll try it here in the browser. There we go. This is not as big of a response. Okay, so base god's 105, base god 706, base god, base god, base god. Come on, do you have something else? Base god, base god. Okay, only base gods. Dang it. Let's find someone else that has some other NFTs. Maybe this one. Base god, base god, base god, base god. Come on. Maybe on ETH. Man. Hey, this person has NFTs on ETH. There we go. So what is this? The door dorsal origin. And then, oh yeah, now we got some spam NFTs. Maybe we should have removed that. But you can see blue Korea Genesis item, also possible spam, true. This is spam. Let's see if they have anything that's not spam. Exclude spam, true. We're really testing out the power here of the API. Oh, here we go. Ballers Collective. Okay, so this person has a lot of NFTs on ETH. And there you see the power. Like, this is cross many collections. So a subgraph could not index this type of endpoint for you. But you can do that, and then of course you have things like token API for ERC20 tokens, also across all networks. You have price API to build, token prices, build charts, candlestick stuff, NFT prices. You can get things like native balance. You can get transactions, transfers. It's really a holistic API in that sense, comprehensive, full of data. And with that demonstration out of the way, and by the way, if you want to get started with the Moralis API, you can do so for free. Just head over to moralis.io, or from the docs, you can click here to get an API key and sign up over at moralis.io. Well, now I got signed in. Sign up over at moralis.io. And yeah, this API is used by many of the largest projects in crypto. We support a lot of chains, including Base. So check that out. In the meantime, I think now that our subgraph might be synced up. There you go. 100% synced up. Maybe yours need a bit longer, because I've been in the meantime doing some magic behind the scenes with editing here. So maybe yours is still not synced up. In that case, you can pause the video and continue in a bit. But for me, I can go ahead and play around with this data now. So if you click on Playground, and then you can click on this button on the right to kind of open up this side menu. And here you can see all of the different things that we can query. And what's interesting at the moment that we can query are the transfers. And all of these, by the way, are based on the events that exist in the contract, in the API. And the first things here are more sorting related, or how we want to query. And then the purple ones are the actual data points that we can include. Okay. And we can get the first 10, for example, the first 10 transfers, and we include all of these data points. Let's see, and here we go. Now we get back transfers. So this transfer was in this block number. It was from this address to this address. It transferred token ID 312, and here's the transaction hash. And then it goes on like that. And you can get, the first 100, and then you get a lot more. So this is how you query data with GraphQL. And you can of course do this through API by using the HTTP URL. I'll show you that later. But the problem with this is that this doesn't give us that much data. Sure, we can query for transfers, we can query for approvals, we can query for metadata updates, but things like balances or owners does not really exist here. And the reason for that is that in order to get to like a list of owners, we will need to look at all of the transfers and kind of build up a list of owners and add and remove owners as transfers happen. And the same thing, just to query for all tokens, doesn't really exist here either. We haven't indexed for that. So we're gonna have to modify our, and also like metadata doesn't exist there, because the metadata is something that we need to query off-chain from IPFS or from other servers. You can see that it's missing here from this response. So we have quite a lot of things to do in order to get this up to par with the API, but we're going to do it as an exercise. And that means that we're going to need to get back into our code and modify our schema a bit in order for this to also index the metadata, the image, and the IPFS URL, things like that. And yeah, this is because NFTs have their metadata off-chain. They're not part of the token contract. So we need to get the IPFS URL from the contract, fetch that, the metadata, extract the JSON, get like the token name, the metadata, and the image from the JSON, and add that into our subgraph. And in order to do this in a relatively quick way, I've prepared the changes that we need to make, and I'll explain them to you as we go along. But you need to open up your code editor, of course, and then you also need to follow the link in the description to my GitHub page, where you'll find this base NFT subgraph, and you need to make sure that you're on the final version branch. And I will make sure that the link goes here, but just in case something goes wrong, make sure that you've selected the final version branch, because when you check this out, there'll probably be some other branches here as well. And where we're going to start is in the schema.graphql. So open that up. And if we scroll down to the very bottom, I've added 3 new entities that are not part of the auto-generated schema. And it's token metadata, and user. And we can start with token. So that defines an entity called token that holds the token ID, or this is a unique ID, and then we have the token ID. And then, because the ID is present in all of these as a unique identifier for the entity. But then we also have the token ID, we have the token URI, we have the IPFS hash URI, and this will become the metadata, updated at timestamp, and the owner of that token. And the owner, it points to a user entity, and that is this user entity right here at the bottom. Let me see, I'll zoom in a bit more. Here we go. Yeah, we can take this one since we refer to it. The user just has a unique identifier and then an array of tokens that they own. And you can see that this is derived from a field owner. So this refers back to the token entity. So this is some the graph magic, some subgraph magic, where this will automatically populate this array based on the owner of the token. And then we have the token metadata field, and we can modify this to include whatever metadata we want. But in this case, we have the unique identifier, we also have the image, we have the name, and we have the metadata. And this will be the full JSON string, and this will be a link to the image, and this will be the name of the token. So you're going to need to copy these three entities and go into your editor and add them to schema.graphql and add them to the bottom here below the transfer entity. Paste them in there and save. And next up, we're going to go into the subgraph.yaml, and we'll need to do that first of all in GitHub. Let's see. We'll go back and we'll go to the subgraph.yaml, and here we're going to need to, let's see, do we need anything here? I don't think so. I think the only thing we need to do is to copy the templates part here. And this is the part that will handle the data retrieval for our IPFS file. And this is something that's it's built into the graph that's called file data sources. And what it will do is it will specify what kind of data this is. We'll say it's IPFS file / IPFS. And then we will specify a handler for it, basically the function that will deal with, once the retrieval is done, it will call the handle metadata function, and there we'll process the JSON and we can update our entity. It also specifies which entities that we're working with and the ABI, which we already have. So we're going to copy this template part. The rest can remain the same because we're not introducing any new event handlers. So you can just copy that template part and go into your subgraph.yaml, and at the bottom here, paste that in like so. And if you get any errors with this file data sources, this type of template, make sure that you have the latest thegraph CLI installed. You'll also need to make sure that all of your file names and so on are correct, so that your ABI is in the right folder. So we have base goals.json in the ABI folder. We have the source file base-gods.ts in our source file, or source folder, sorry. That should be it for that. So make sure that you have all of that set up. And next up, we're going to go into our base.god.ts file and do some modifications in here. Here is where we handle each of the events. So the handle transfer function here is called every time there is a transfer, and we create a new entity and we set the properties we want on that entity, and then we save it. And this is also where we're going to work with our users, our owners, and our metadata. We can update that on every transfer. So back to GitHub we go, and we're going to go into source base-gods.ts, and we need a few things here from the top. We need these three things: token metadata, and these three kind of helpers from, or types from the graph protocol library. And you also, this also needs to be up to date, by the way, this graph TS library. Make sure you have the latest version of that. And then the IPFS hash, and this is the IPFS hash of the collection. And so we'll copy these three statements and add them into our on the top of our underneath the other import statements. There we go. And yeah, this IPFS has just got it from the base scan collection here. So I went in here and checked the base URI, and you can see that here. Once we have that, we're also going to need to add from our generated schema here, we're going to have to add user, what else? We can copy this token and token metadata to the end of that. And these have not been generated yet, so we're actually going to open up our terminal and run the code gen function, which will generate this schema for us. So we're going to run graph code gen inside of our base NFTs folder, of course. There we go. Now that's going to generate inside of the generated folder. That's going to generate this templates file, for example, that we're going to need for this token metadata. And it will also update the schema here to include things like token metadata and let's see here. And the user entity, let's see where that is. User. So it bases that on our schema file. Now we got that, we got this, the IPFS hash, then we can go back to GitHub and we're done with the whole import thing here. And we can go down to the very bottom where we have, first of all, the handle transfer function. And this is a lot longer here in GitHub than what it is in our code. Because if we go down on our code, you can see that we are handle transfer. It's a lot shorter, this function. And that's because at the end here, I've added things to handle the ownership and the metadata fetching. So we'll take the, from GitHub, we'll take everything below here, the first entity.save. You'll copy this here from token.load all the way down to the last line of the function. And we'll copy that and paste it in here. And let me see here, we'll do some clean up there. Okay, so what are we doing here? Well, first of all, we're loading in from our subgraph to see, is there already a token entity with this token ID? If there is not, we need to create it. We'll create it here using the token ID as the identifier. And then we set the properties of this token. And first of all, we're going to set the token URI. And this will just be whatever comes after the IPFS hash in the metadata URL. So that'll be slash followed by the token ID. And I know this by also, once again, looking at the contract. So looking at the contract in Basecamp, you can go down to token URI, and you can input like just a test token ID here. You can see that the URL here is the IPFS hash /1. So there is no like additional path or anything, but for some collections you will have like slash metadata slash the token ID or something. But here it is just slash followed by the token ID. And then we're going to get the full IPFS hash URI. So that would be the IPFS hash that we set at the top up here plus this token URI. And that will form the full URI that we need. We'll also set that in the token. And then we will do token metadata template dot create with the full IPFS hash URI. And this is now part of this file data sources from built into this subgraph. And what this will do is that it will fetch from IPFS this JSON file and put that into this token metadata template, which we will handle in a later function where we'll define what happens when this loads. So we'll get back to that in a second. But once that happens, then we're done with like the creation of the token, because these things will never change again. So once the token is created once, we set this one time, but then next time there's a transfer and this token already exists, we'll skip this part and go just to the updating the timestamp and updating the owner, because that changes on every transfer. So we're getting the to address of the transfer, setting that as the owner, then we do token.save. And then we're also updating and creating the user object. So if that doesn't exist, we'll create the user object and save that. And that's all that we need to do. We don't set any other properties of the user, but the user object is there solely for us to be able to fetch all the tokens by owners. So that's the thing that we need to do on transfer. So what we've done here is we've created tokens, and we keep tokens and their owners up to date, and we create the metadata, or at least we fetch the metadata. And now we need to handle that metadata object. So we'll go back to GitHub and we'll scroll down here to the bottom of this basecodes.ts file, where we'll find the handle metadata function. And we will copy that whole thing, pull that into the very bottom. So we'll be now also outside of this handle transfer function. So at the very bottom, we'll paste this in here. And this function will be called as part of this template. So if we go back to our YAML file, in the template we specified, we put the handler as handle metadata in the basecodes.ts file. So that is this function. And this will be called once the token metadata template has fetched the JSON file from IPFS, and that will come into here as the content. And so what we need to do every time that we find new metadata is to create a new metadata object, and then we'll create this JSON mapping so that we can query the actual values from this JSON object. And if that is successful, down here then, we'll get the image and the name. And if we can successfully find those, we'll set that. And here I see a mistake. I added this metadata field last minute here. So we're also going to add that here to make sure that we check so that it actually exists. So this will be the full metadata string. I'll get that just from content.toString. And if all of these three exist, which they should do for every token, then we will set that into the token metadata object and then save it, or the entity, and save it. And that's all that we need to do. Once we have this, we will now index the owners and users and the metadata of the tokens. So once we have this, we can run graph build. And then we can run our graph deploy command, once again with --studio base NFTs. And we need to specify the version. And now I've been building here quite a lot in the background in order to complete this tutorial code. So for me, this will now be version 0.3.0. And there's deployed. We'll go back to Subgraph Studio, and now we'll be back to syncing again. And this is something that you have to do every time that you deploy something new. You have to go through the syncing process again. And that can take, once again, 15 to 20 minutes. One of the main benefits of working with an API like Moralis is that you don't have to wait for it to resync every time. And now you're quite lucky because you're following a code example that I've prepared, and I've gone through and built this, and it's taken me quite a few iterations to get it right. You make some small mistakes here and there, you forget some things, and each time you see the log, you see that something is missing or you get an error, you have to re-index and resync, and that can be quite frustrating. So we're gonna, well, if you don't like that, then you should use the API. And now we're gonna cut the video, you can pause it, and we'll come back here when this is fully synced up, and hopefully we didn't make any errors. Okay, so now we're fully synced up, and let's see here if we actually did the right thing here. So once again, we'll click on the right hand side here, and yeah, we'll also delete all of this here, and then we go down to users, and we get first 10 users, let's say, and we also want to get their tokens. So we unfold this tokens entity, and we select the ID. We can select the, well, let's just take the ID, image, metadata, name from IPFS hash URI. This is what became the metadata. And query. Boom. So we now have a users array, and in the users array we have tokens, or we have users where you can see the address is actually at the bottom. I think it will be easier if we copy this and we inspect, we open up the console here, and I will open up this as a JSON object. So here we see an array of users. Can I make this bigger? Yes. An array of users, and for each user you have tokens with the well, this is not the ID. Okay, so now we put the ID as the IPFS hash slash the token ID, but yeah, that's maybe something we can fix. We got the image, so if you copy this, you will see that it is indeed the NFT image. Then you have the full metadata as a string, so you can easily in your application convert this to a JSON object. You have the name, description, all the traits, etc. And you have the name, base code, and you get this for all the tokens for this user. There you go. And with this data, you can also query them for specific users. So you can query for user, let's see, user where ID is equal to something. Now let's see, what did we use for ID? Maybe we didn't use the address. No, we, let's see. If we didn't use the address, then we might be in trouble. Include the ID. Let's go. Yeah, we did. So you can take an ID and you can query for user where the ID is equal to that, let's say. You should be able to do that. And we want to include not the ID maybe, but all of the tokens. We'll include query. Boom. Now we get the tokens for this specific user. And this person holds 1 token. Was that correct? I hope it was. Oh no, we didn't have that here. We didn't bring the ID. There we go. That's how subgraphs work. And hopefully now you also got a clue about not only how to do this, but how they actually work. So you can add on things into this subgraph to query more things. So you can query now also for tokens by their token ID. You can get back their metadata. You can get back all of the owners. So there's now a lot more that you can do with this subgraphs, with this subgraph. However, once again, the benefit of using something like the Moralis API is that you have to do no syncing. You have this for all of the NFT collections in the world, not just on Base, but on all of the chains. And you also have the same thing for ERC20 tokens, for normal transactions, for wallet history, for prices. So it depends on the use case, as we discussed in the beginning. But I would definitely go ahead and try the Moralis API together with your subgraph. I mean, the other problem with the subgraph here is that, sure, you get the image as IPFS hash, but this image is 3000 by 3000 pixels. If you try to load that into your like tiny wallet with like tiny images, it's gonna take forever to load if you have many NFTs in there. Same thing with like the metadata. If you're building an app with many different NFTs displayed in it, you will have a problem because the traits across different NFT collections are not formatted the same. And that's going to become a big issue. In Moralis, with that formatted metadata, we format it all into the same format. And the image is processed to different resolutions. And then you also have all of the other things like NFT prices, floor prices, things like that in the Moralis API. So there's a lot of things that you get for free by using an API that you would have to work very, very hard at to do with the subgraph. And then that's only for one collection on one chain. So take that in mind and decide which solution is best for your specific use case. But I hope that you enjoyed this video. And if you did, make sure to leave a like and subscribe to the channel. Leave a comment down below if you have any questions or maybe ideas for future videos on Base, on subgraphs, or on the Moralis API. You'll find all of the code listed in the description below, so you can follow along there. Thank you for watching, and I'll see you in the next video.